Hey everybody, this is Matt Brown. I hope you're having a good day. Today we are going to take a look at another hardware hacking project I've been working on. Today I've got a cable modem. It's the RS6121 surfboard cable modem. And today we're going to be extracting its firmware contents using chip-off firmware extraction and a universal programmer. I have tried to do several other hardware hacking techniques on this, trying to find UART, a couple other things. None of that has panned out, and so the last resort, what we are left with is trying to pull the flash off of the board and reattaching it, potentially. But without further ado, let's go over the desk and see what we're dealing with today. So you can see here, I've got the PCB of this cable modem. This side we've got the CPU, RAM, and then over here is where the power cord is. So I got this device used without a power cord, and so I had to connect that to a benchtop power supply. I was hoping to be able to interact with the device over the Ethernet port, but I don't think that that is active until the cable side is active, and I do not have any way to simulate the internet side of this modem over this interface. If anybody has any good way to emulate that, like with a Raspberry Pi or something, that would be very useful. But today, what we're going to look at is the flash chip right here, which we will look at now under the microscope. I will flip over to the desk, and you can see, I'll center that up for us. There is our flash chip, and if I take a flashlight, do our technique of where I shine sideways across the chip, you can see that we can make out the model number of this Winbond flash chip, and I have gone ahead and written that down. And so I'm going to pop over to my screen for a second. So here we have the data sheet for this chip. We can see that this specific flash chip actually comes in a few different package types. So obviously I've scrolled through this document to find the one that is the 16-pin SOIC chip. And so now I'm going to go look in my software for my firmware reader, because one thing that I like to make sure of before I do pull a chip off a board, because every time you do that, there's some risk involved in that of breaking the device or ruining the flash chip, something like that. I like to have a good idea that my device reader, that my flash reader is going to be able to read the specific chip I have in mind. So I'm going to switch over to that window, and here is the XKaku software. It's sketchy Chinese software that I run under Wine. I've mentioned in past videos there's a really cool person who has implemented the libUSB stuff for Linux, and so big shout out to that project. I'll probably relink it in the description again, but you can see here I've selected my specific version of this chip. Again, it's got the correct model number of the flash chip, as well as this SOIC 16. That's the package. That's the configuration that chip is in on my board. So I select that. See, and this is what happens. See, all these options down here are all blurred out. I actually know that none of those matter, but it's really annoying. So you might ask yourself, okay, why? So there are two versions of this. There's like an old version and a new version of the reader, and you might have noticed on the desk I have the old one there. Well, it's because in this part of this software, oftentimes it will give you like a really bad or unhelpful picture here, but in this case, the diagram for which socket to use for this specific chip, it it looks good and it looks like the right one for the old version of the reader, but the new one, the picture's really confusing, and I could try to guess and check where exactly to set the pin in, but set the chip in the certain pin configuration, but I don't want to bother with that, so this is going to work out just fine for me. So I have all the software ready to go, and I have a good idea that I am going to be able to read it with my reader. So that is all good. So now we're going to go back to the desk and get this out of the way. And I'm just going to show you my prep, and then we're going to go back under the microscope. So here I've got my hot air, and you can see as soon as I take it off of the magnetic stand, it starts blowing hot air. So I'm going to put that back over there, so that stops for now. And I am actually going to put on gloves, because the other thing that we're going to be working with is this flux, and I don't like to get that on my hands. So I'm just going to put on these gloves. And then the other thing I have right here is some isopropyl alcohol that'll help us clean off the flux residue from the chip as well as the board after we have pulled that off the board. The other thing I have on hand here and here, I've got some solder just for replacing the bad solder that's going to be on this board if I'm going to reattach this chip after this operation, as well as some solder braid to pull solder off of the chip and of the board. And yeah, so those are the supplies that we're working with today. I've got some Q-tips as well that we're going to use for the cleaning. So now we're going to swing the microscope back around and switch over. And we're going to get our chip nice and in the center there. So now what we're going to do, I'm going to take my flux and I'm going to just give a healthy amount of flux over where the legs of this chip are at. I'm going to set that to the side. And now I'm going to have, in one hand, I've got my hot air, and then in the other hand, I've got my tweezers. And then I'm going to, actually should have turned this the other way. Okay, we're gonna rotate it so that it's easier for me to grab this chip when it comes off. So I am trying to heat the whole circuit board at first, because what you don't want to do when you're pulling a chip off a board like this, you don't want to create a big difference in heat from one part of the circuit board to the other. That can cause some wonky things to happen. So I'm just throwing hot air all around, not just on the chip. And so I've done that for about 20 seconds. I'm going to throw even more flux. I'm just going to throw a Lewis Rossmann amount of flux on there. So yeah. And so now I am going to focus my heat right on the center of that chip and kind of go back and forth on the legs. And now, again, it's really important to note that when we pull a chip off a board like this, we don't want to actually pull it off the board. We want to get it heated up to the point where it just kind of comes off like butter. Because otherwise you risk ripping pads off of the circuit board, and those are really hard to repair. So I'm just kind of nudging it, seeing if it's going to, if it's ready to come up. It is not. I'm not going to force it. And I'm just going to just keep throwing heat targeted at the chip. With a chip that has legs exposed like that, I do like to go up and down the legs, the sides of the chip, because then that does let me see when they start to get shiny that they should be ready to go. Man, that's still hanging on. So I'm gonna try to give it some more flux. And I'm gonna turn on my fume extractor because I don't wanna breathe this stuff in. That's what that noise is. are still like locked in. Okay. Okay. I wanted to pull it off there because it wiggled, but I'm not going to. I'm just going to keep applying heat. I'm going to get a good hold of it. Okay, now I feel it coming up. It's starting to move. There we go. Now like butter. It's off. Okay, now I'm going to put my hot air back on the station. And the first thing I'm going to do, I have a lot of flux on here. So I'm just going to take some isopropyl alcohol and my Q-tip. I'm just going to try to manage some of that mess that I made on the circuit board. And that's pretty good. It's not perfect, but we've got that taken care of. And now I'm going to turn the fume extractor off because I should be good there. I'm going to pull the board out of the way, and we're going to put our chip center stage here. So the top and bottom of this are still covered in flux. So what I'm going to do now is we're going to take more isopropyl alcohol on my Q-tip, and we're just going to kind of go back and forth here. So this is always hard with these legs, especially when you're cleaning this side of it, because you don't want to get all these fibers stuck. So all I can do is go down the middle. I don't want to, and even then, I'm going to get some fibers stuck on it. So now flipping it over, it's not as bad because you can like kind of go with the grain of the pins, and it shouldn't be too bad. Okay. Whoa! Just shot the chip off to the side. Okay. So that was a good first pass. So now I'm gonna bring my my hot air back out just for a second, and here I'm not really heating it too much, but I'm just going to try to evaporate as much of that alcohol as I can. And then I'm gonna move the chip off to a new clean spot, and I'm actually gonna try to switch to a different set of tweezers. I kind of like to have a dirty and a clean set of tweezers, so I can kind of separate those. Okay, and I'm just gonna give this another little clean there. I'm gonna go back to my hot air a little bit, get all of that evaporated. I think we're good there. The other thing that I'm gonna want to do to this chip, especially with these legs here, there's the potential that there's still a lot of solder on these legs here. So what I'm gonna do, I'm gonna go ahead and take a look at that right now. So that will affect the ability to read. Whoops. And actually, look, yeah. So you can kind of see up here. Oh, I'm a little bit out of view there. So up here, there are actually some solder balls still up there on those legs, and so that can affect the reader's ability to make a good connection with every part of the chip. So what we're gonna do is I'm gonna get my solder braid out and my soldering iron. Gotta find my shears and just cut me off a little bit of this. Okay, and then soldering iron and braid. All right, you know what? It's gonna be easier to have it zoomed out because then you can see it there at home. All right, so now I'm just cleaning these legs, and I don't want to push too hard because I don't want to bend these pins out of alignment. And here I got this, I kind of got it stuck, so I'm just kind of like letting it pull the solder off of the pins into the braid. So that's what this braid does, is when it has heat applied to it, it basically collects the solder on it instead of on the component. Okay, now we're going to do the other side. And this chip is hot, and I'm touching it with my finger. But, you know, if you just do it momentarily, you won't get burned. All right. And when you see it smoking, that's when you know it's doing its work. That's when you know it's pulling the solder onto the braid. Okay, that looks pretty good. And so now that braid also introduces impurities. So then I'm just going to go once more with isopropyl. And then, yeah, the back side is not as important. But there we go. Nice and clean. We're just going to throw a little more hot air, evaporate that all off. And now we have successfully extracted and cleaned the flash chip. And so now we're going to go with the big view again. So now what we're going to do is we're going to place that chip into this reader. And so again, I'm going to kind of flip back and forth here. Take these gloves off. Don't need those anymore. So if you look at my screenshot here, we can see that here for this older reader, the picture is giving me a good representation of what orientation the socket as well as the chip inside of the socket should, how all of those should sit. So back here on the desk, so I've got that set. So up here is where it wants me to be setting this socket, and then the chip is, I should go right back to the screen again. You can see here that this circle is the pin 1 indicator. So it wants pin 1 all the way up at the top. So over here, what that means is, okay, this is actually something I can show in the microscope real quick. Here's our chip. There we can see the circle, and this is really confusing because there's like, oh, there's 2 circles. It's actually this circle. This is just some, this is actually not like some piece of paint or something like that. But this circle is actually the pin 1 indicator. So I'm going to hold the chip like this, and I'm going to set it into the reader like so. And my camera is not refocusing. That's awesome. So, and I just knocked it out. Okay. And then, again, the microscope is a lifesaver for something like this, because now what I can use the microscope to do is verify that this reader is not, that the chip is set in there correctly. So let me get zoomed out, and I need to get focused. Okay. Okay. That. Okay, we are having trouble focusing. Okay, I'm gonna have to take it out of the reader. It's not, there we go. Now it focuses great. Okay, so now we can use this to actually inspect that we are indeed all lined up. The reader, receptacles for the pins are perfectly lined up. That's good to see. So now we just drop that in, and then this lever throws down there, and now we've got the socket inside the reader, the chip is in the socket, it's secured, and we should now be ready to read our firmware. So if we go over here, and we've got it all set up, we've got the correct chip selected. So I'm going to go to device, and I'm going to say read. I'm going to say read, and it's going to say it found bad pins. Okay, so this could be one of a few things, and I'm going to tell it to ignore the problem. Okay, so it says check ID is FFFFF. That is an indicator of an error. So, yeah, cancel. Man. Okay, so fun times. Let me look. All right, we're gonna try again. I just fiddled around with it, and this is how you do it. This is how working with this reader is, and just like that, I poked it around a little bit, and then the connection was good. Maybe I didn't pull all the solder off of those two pins, and it was uneven. Who knows? But now we were able to pull our firmware off, and so now if we go over to here to the flash section, we can see that it actually did extract some data. So what we're going to do is we're then going to go in here, and we're going to click save, and I'm going to save it. We're going to go save this off. Where do I want to save this? Home. All right. Here we go. Bam. All right, file has been saved. There it is. And now we are going to open, I've already got a shell, and we're going to copy that file that that binary that we just saved off to our system. It's in here somewhere. I gotta remember what it's called. Oh yeah, it's gonna be like W something. There it is. I'm gonna move it over to this folder. And now we can take a look at the firmware that we extracted. Okay, so file on it. It's like, okay, it's this thing. All right, and now we can use binwalk. And okay, that shows some interesting stuff. Probably a bunch of that is not legit. We see some mentions of SquashFS file systems. This is a good sign. This means that we could potentially have a Linux root file system in here. So I just ran binwalk without any options. That doesn't do any extractions, right? So now we're gonna add the -e flag, and we're gonna get a bunch of errors, and we're gonna see what it extracted. Okay, so there's a bunch of junk in there. That happens a lot when you work with this stuff. Okay, so we can see a couple SquashFS root file systems that actually got extracted, and here we have a real folder. Okay. Yeah, I don't. Let's see what we got here. Okay, there's just some stuff in web. Here we go. There's some HTML and some JavaScript. Okay, so looks like it's some kind of a web application. That's interesting. All right, now let's go back, because there was another SquashFS that actually got successfully extracted. Right. This is what happens when you pull Flash off of a chip like this. Is there might be more root file systems than this that are legit, but well, wait a minute. Okay, so that's web also. Hang on. Those, oh, these are directories. Oh, okay. Well, let me go in there then. Oh, score. Score. This is awesome. Run find. Okay. There is actually stuff in here. This is great. This is really great. Okay. Awesome. So now we're inside our root file system. We can do things like look for Etsy password. There's nothing in there. Etsy shadow. There's also nothing in there. Okay. That's fascinating. Are there any like real files inside of here? Okay. Okay, a bunch of this stuff is not actually live. Okay. But there's other things. Yeah. Shadow is just pointing to devnull. Password is pointing to devnull. What's this config? Okay. I don't know what this is. Let's see. Yeah, very interesting. Very interesting. Yeah, this is some kind of system build config almost is like what it looks like. Services. That's just the standard services file. Ooh. All right. Yeah. So this is a Linux file system. That's really interesting. Var. Why is there a tar file sitting there? See, now I just have to untar it. We're gonna let's see what's inside here. Okay. There's like actually, you know. Let's look. What do we got? Ooh, temp shadow. So a lot of times on embedded systems, right, Etsy shadow is just like a symlink to some temporary file. So let's see what this is. That is, it doesn't have an entry. That's interesting. Okay, it just has the root user. Okay, so not a real like password hash or anything like that, but anything, or if I got, let's just do this. See if there's anything else interesting in here. Yeah, what's the gateway files? What's the temp gateway? Nothing. Okay, so now we can like go for broke and let's look for like password in squashfs, blah. Let's make it case insensitive. Let's just see what this gives us. Is there anything useful? So there's something with the web login. That's interesting. Okay, I'm seeing a bunch of these SO files. These all look to me, except for things like libcrypto, that's OpenSSL, right? Or some other SSL library. But some of these other libraries look like custom code, like where their custom stuff for this modem lives. That would be a good target for reverse engineering of something, right? That's where you would want that to live. So, okay, this is interesting. There's some kind of config, login. It's mentioning, because this file is at least mentioning the existence of some sort of a password. Let's scroll down. Let's see if we can find anything. Like, I don't think there's anything glaring there. Like that's obviously a password. What's this? Config. It mentions a password somewhere. Login, password management utilities. Okay, config add shell. Yes. Config remove shell is not set. Config use bbcrypt. Okay, so this is just, again, that's in that config file. So here you can see that we were able to recover the root file system from this device. There's multiple file systems there. Probably some of those get mounted read-only when the system boots, and some of them get mounted over certain directories of the root file system. It gets mounted writable, some of those other partitions that don't have as much data in it. That's usually how these embedded devices work. But this is just a quick look into how we were able to extract firmware from this device. And even though I wasn't able to get a UART shell, we're still able to get some critical information on this device that could be used to develop exploits or reverse engineer and understand how the device works in the future. So thank you for watching this video. Please like, comment, and subscribe, and have a great day.